Hi everyone, today we are going to be talking about measurement division with fractions. So our example problem is 2/5 divided by 7/3. So what I've done is I've created this, I've made this into a word problem, so that's a little easier to understand the definition of measurement division when it comes to working with fractions. So if we have 2/5 of a cake, and we want to divide 7/3 of a cake equally among a certain number of classes, like classrooms, how many classes will get one cake? Or how many classes will get 7/3 of a cake? So that's the question that we're trying to answer. So an important thing to remember with measurement division is that our whole is going to change. So we're going to go from a cake to classes. So first what I want to do is I'm going to draw 2/5 of a cake. So if I have one cake, and I divide it into 5 pieces because our denominator is 5. Our whole is going to be this one cake. And then we have 2/5 of that cake. Next what I'm going to do is I'm going to draw 7/3 of a cake. So what the 7/3 represents is that's how much cake we want to give to each classroom. So if we have 7/3, because it's an improper fraction, we're going to need to draw 3 whole cakes. But our whole is just going to remain this one cake. So then we're going to split this into thirds. And then we have 7 pieces. We don't technically have these 7 pieces, but we want to give 7 pieces, 7/3 of a cake to each class. So next what I want to do is I want to make these pieces equal sized. So the way I do that is because we split these cakes into thirds, I'm also going to split the cake that we split into fifths also into thirds. So I do that by drawing the lines this way. And because these cakes were split into thirds, I'm going to split them into fifths. Again, this is so we have equal sized pieces. An equal sized pieces and an equal number of pieces in each cake. So now if we're going to kind of pull this apart, so we're going to ignore the fractions for a minute and we're going to look at just the total number of pieces of our cake that we have. So here we have 6 shaded pieces, so that's 6 pieces of cake total. And we're going to think about this as integers now. So we have 6 pieces of a cake that's been cut into 35 pieces. Or 15 pieces, sorry. And then we have, down here, we have 15, 30, 35 total pieces. And again, we're just looking at the total number of shaded pieces. We're not acknowledging the fractions at this point. So we had 6 and then 35. So now if we were to look at these as just pieces, we pull them out and we say we have 6 pieces and we want to divide that, so we do that fraction bar because we know that's the same thing as dividing. And then we are dividing it among 35. And that's going to be our final answer. And the reason that we can do this is because the reason that our answer is going to be a fraction is because we don't have enough cake to give each class 7/3 of a cake. So we only had enough to give 6/35 of a class 7/3 of a cake. And this is going to be the same as when we invert and multiply. So we have 2/5 times 3/7. So we inverted this fraction, changed to multiplication, and now we're going to multiply across. So we have 2 times 3, that's the same as these 2 groups of 3. And 5 times 7, that's the same as these 5 groups of 7. So then we multiply across and we get 6/35. And that's going to be your final answer. So going back to the whole, we asked how many classes will get 7/3 of a cake. 6/35 of a class will get 7/3 of a cake.